All right, welcome. Today, we are going to pull back the curtain on the hidden engine of the internet. We're going to demystify the fundamental rules that honestly make our entire digital world spin.
I mean, really think about it for a second. How does one simple click on your screen somehow connect you to a server that could be thousands of miles away, and it does it in less than a second? It's not magic, but it is an unbelievably elegant system.
So, the secret sauce is a protocol suite called TCP/IP. That stands for Transmission Control Protocol/Internet Protocol. Now, you can just think of this as the universal language of the internet. It's the one set of rules that governs how all our devices talk to each other. From our phones asking for information, which we call clients, to the massive computers that provide it, the servers. And get this isn't some newfangled invention. TCP/IP has been the absolute bedrock of our digital world for decades. It actually goes all the way back to the 1970s, developed by the U.S. Department of Defense for a project called ARPANET. That was basically the granddaddy of today's internet. By the 80s, it was the global standard, and it's stayed that way ever since. So how does it actually work? Well, the entire TCP/IP model is built on this really clever four-layer structure: application, transport, internet, and network interface. And the genius of it is that each layer has a very specific job to do, which makes the whole system incredibly tough and adaptable. So we're going to take a journey through each one, from the top all the way down to the bottom, to see exactly how your data makes its amazing trip across the web. So our journey starts right at the top, with layer 4, the application layer. This is the one we all interact with every single day, even if we don't realize it. Okay, so this is where your actions and the data itself connect. When you open your web browser, your computer is using what's called the Hypertext Transfer Protocol, or HTTP. Sending an email, that's the Simple Mail Transfer Protocol, or SMTP. These are all what we call high-level APIs, which is really just a fancy way of saying they give our apps a standard way to talk to the network without needing to know all the messy, low-level details. Basically, this layer turns what you want to do into actual data. The easiest way to wrap your head around this is with a simple postal analogy. Think of the application layer as you sitting down to write a letter. The actual words you write on the page, that's your data, like a request for a web page. And the language you write it in, well, that's the protocol, like HTTP. So at this point, our letter is written and it's ready to go. All right, our letter is written. But now we need to get it ready for a safe and, really important, a reliable delivery. And that brings us down to layer 3, the transport layer. The main job of the transport layer is all about reliability. Its whole purpose is to make sure your data gets from point A to point B completely intact with no errors. And the star player here is TCP. It handles all the error checking and makes sure everything arrives in the right order. You can kind of think of it as the internet's quality control department. So let's go back to our postal analogy. Imagine your letter is, 100 pages long. Instead of stuffing it into one giant envelope, the transport layer breaks it all down into smaller pieces called packets. It's like putting each page into its own separate numbered envelope. And TCP's job is to make absolutely sure every single one of those envelopes arrives, and then helps put them back together in the correct order. Okay, so our message is perfectly packaged up and all the pieces are numbered, but it doesn't have an address. And that's the crucial job of layer 2, the internet layer. This layer, right here, is really the heart of the internet part of TCP/IP. It's all about logical addressing and routing. And the main protocol is IP, the Internet Protocol, which gives a unique IP address to every single device on the network. This is what allows routers to figure out the best possible path for your data to travel across the entire globe. Back to our analogy, this is the part where we write the full to and from addresses on each one of those little envelopes. That IP address, that's the global delivery address. And the routers we just mentioned, well, they act just like post offices and sorting facilities. They look at the address on each packet and send it along the most efficient route to its final destination. So our package is sealed, it's numbered, and it's addressed. There is just one final step left, the actual physical journey. And that's the job of our final layer, layer 1, the network interface layer. This is where the digital world becomes physical. This layer takes our digital packets and literally converts them into electrical signals to go down an Ethernet cable or radio waves for Wi-Fi. It's all about the physical hardware, like your computer's network card and the switches in your wall, that handle the actual sending of data. And to finish our postal analogy once and for all, This is the mail truck. It's the cargo plane, the delivery van. It's the physical vehicle that takes our perfectly prepared package and actually carries it from your house, your local network, out into that huge global postal system. So let's just recap that journey real quick. We started with an idea and an application. We packaged it up for a safe trip. We slapped an address on it for the global internet, and then we finally sent it out over the physical network. You've just followed a single piece of data from your click all the way down to the actual wires. Pretty cool, right? And what about the computer on the other end? Well, it just does the exact same process, but in reverse. It's like unboxing a delivery. It takes the physical signals from the network interface, reassembles the addressed packets at the internet layer, unpacks the data at the transport layer, and finally, it hands the original message to the right application. It's a simple, elegant, and just incredibly effective system. You know, when you take a step back, it is truly remarkable. This model is nearly 50 years old. It was designed decades before things like streaming video or social media were even a dream. And yet, it's the silent, super robust foundation for pretty much everything we do online. So why has it lasted so long? Why does it still rule the web? Well, a few key reasons. First, it's a universal standard. That means any two devices, no matter who made them or how old they are, can talk to each other. Second, that layered design makes it incredibly reliable and way easier to fix when things go wrong. And finally, it's the versatile hidden architecture that powers everything: email, streaming, gaming, you name it. And all that leaves us with a really fascinating question to ponder. This almost 50-year-old model powers our entire hyper-connected modern world. It's proven itself to be unbelievably resilient and adaptable. So you have to wonder, what will the next one look like? And what incredible new possibilities is it going to unlock for all of us?